Define h from R to R cross R as follows. H of xy equals x plus 1 comma 2 minus y for every x comma y in R cross R is h 1 to 1. Now this is a little weird because our domain here consists of ordered pairs R cross R. If you've taken multivariable calculus or Calc 3, then you might be familiar with this setup here if you've seen those 3D functions where the inputs include x and y as the inputs. But what you may not have seen before is that the codomain represents R cross R. In Calc 3 and multivariable calculus, the outputs of these functions is usually just like the z-axis. It's usually just like a number at the end. But these outputs are ordered pairs themselves as well, which changes things a little bit. Part A asks, is h 1 to 1? Meaning, is every output of this function unique? Now, the setup of this proof is going to look a lot different. We're going to start with two elements in our domain, and we're going to assume that we have two outputs here. These are the outputs of the function after we've plugged in these ordered pairs into the function. If we assume that these two outputs are the same, we want to show that the corresponding inputs must therefore also be the same. That would show that this is 1 to 1. Now we can use the definition of the function to evaluate what these outputs are. This is x1 plus 1, comma 2 minus y1. And the right side is pretty much the same thing. Now the only way these two ordered pairs are the same is if they have the same entries in both coordinates, which means that these two entries have to be the same, and these two entries have to be the same. So x1 plus 1 has to equal x2 plus 1, and if you subtract 1 on both sides here, we get that x1 equals x2. In addition, 2 minus y1 equals 2 minus y2. We can subtract 2 on both sides to get negative y1 equals negative y2, and then we can multiply both sides by negative 1 to get y1 equals y2. It's really important in this case to show that both of these equal each other. Normally, we're used to setting f of x1 equal to f of x2 and proving that x1 equals x2 here. But our inputs are a lot more complicated. In this case, what we've shown is that the first input, which in and of itself is an ordered pair, is the same thing as the other ordered pair, x2 comma y2. So since these two ordered pairs are the same, then that means that these inputs here to this function, h, are also the same. So by assuming that these two outputs are the same, we have shown that the corresponding inputs must therefore be the same as well. And that proves that h is 1 to 1. The next question is h onto? Meaning we have to start with an arbitrary element in our codomain, which is R cross R. So we're going to let a comma b be an element in R cross R. And we have to ask ourselves if there's an input to this function that gives us the result a comma b. And our input is allowed to include a's and b's as well here. But we just need to find any input from our domain that can map to a comma b. Now, the output of this function is x plus 1 and 2 minus y, but we want a and b. Now, if we want an a in the first position, then it would help to plug in a minus 1, since by adding 1 to a minus 1 plus 1 is just a. So a minus 1 is going to be our input. Y value is going to be a little bit trickier because we need to ensure that 2 minus y equals b. But here we can solve for y by subtracting both sides by 2 and then multiplying both sides by negative 1 to get y equals 2 minus b. And so that is going to be our input, 2 minus b. So if we want the output a comma b, and it doesn't matter what a is, it doesn't matter what b is, we can just plug in a minus 1 comma 2 minus b, and we'll get that a comma b that we're looking for. So for example, let's say we wanted to get the output 3 comma 10. Well, according to this formula, the way we can get that output is by plugging in specifically the input 2 comma 2 minus 10, which is negative 8. And if you check this, if you plug in 2 comma negative 8, you'll end up getting that output 3 comma 10. And so this provides a formula by which we can find the corresponding input for any output. And that means that this function is onto. Like I said, it's really easy to show that a function is not 1 to 1, and it's really easy to show that a function is not onto, but it's way harder to show that a function is one-to-one, and it's way harder to show that a function is onto. Conceptually, I think, as well. This function is both one-to-one and onto. Thanks, everyone, and I'll see you in the next video.